Okay, so my last video lasted 14 seconds, even though I talked about 14 minutes. So instead of erasing everything and writing everything down again, I am just going to talk my way through what I've already written down. So that's why I have this cute little screen to hide it. So this is our last video of the year, our last lesson. You're probably going to want to pause this because I am going to be writing and moving faster than you can probably write, but you should pause it and let things sink in and try to answer the questions that I prompt you with and so forth and so on. Okay, so we've got a wedding venue, cost $2,000 to reserve the date. We're going to also employ a DJ and a security guard. The company charges $25 an hour for each of those. So $25 for a DJ, $25 for the security guard. They want us to write a function that represents the average cost per hour for the wedding. Okay, so that word average right there means that we're going to add something up and we're going to divide by how many we have. Well, what are the things that we're doing? We're talking about our variable here is our hours. Our wedding might be 1 hour, our wedding might be 2 hours, and by wedding, I'm talking wedding and reception, hopefully, not just a wedding that would last several hours. I hope the wedding is just a few minutes and then the reception and everything last hours. Anyway, so we know that we take the $2,000 that it costs to get it in, and then $50. Remember, that's $25 for the DJ, $25 for the security guard, $50 an hour. But then we divide it by how many hours we have. Okay, that's going to be our function. By the way, if you hear people in the background, it's because I'm babysitting right now. Non-testers. So they've been really good about keeping their noise down, so maybe you don't hear them too much in the background. All right, so there's the function. But writing the function is not necessarily all you have to do. You have to be able to write the function and do something with it. One of the things that they're going to ask you about is the domain. Well, we know we're not going to have a wedding that has any negative hours, and we can't have a wedding that has no hours because then we'd be dividing by 0. We can't do that. So our interval is going to be technically from 0 to infinity, but we could technically put a cap on it because we're not going to have a wedding last more than, let's say, 24 hours or something like that. But anyway, we're not going to worry about that right now. We can have decimals. Why can we have decimals? Because you can have a wedding last 2.6 hours, okay? So that means that you want to tell me that X is an element of the reals. That means that this graph can be a continuous graph. When we graph it, if we graphed it, we could plot points, 1 hour costs this much, 2 hours cost this much, 3 hours cost that much. You can have, and then you can connect the dots. In a minute, you're going to see we're going to have one where you can't connect the dots, and we're going to call that discrete. You can also look in your textbook and see an example of that. So being able to talk about what kind of hours you can have and what set of numbers they belong to, that's going to be one thing that you're responsible for. Then they're going to say, okay, let's say we have a 5-hour wedding. They're going to give you a value for X. If they give you a value for X, then all you do, of course, is plug in the 5. The 5 goes here, the 5 goes here. We do the calculations and we figure out that it costs $450 for a 5-hour wedding. Okay. Then they say, okay, we want the wedding to cost an average of $400 an hour. So how long would the wedding be? So in that case, they're giving you a cost, which is a Y value. So you plug in the Y value and you solve for X. How do you get these X's by themselves? Well, the first thing you do is you get rid of this X. So you multiply both sides by X. This X cancels out. This one gets the X. Okay, then you solve for X. Subtract 50 from both sides. Divide by 350. And when you get done, you find out that the wedding can be 5.7 hours and be $350. Okay, like I said, I know I went really, really fast, but just rewind it and watch it again to let all that sink in. Okay, the next problem. I was supposed to have the little tool up there. Where was the little revealer? There it is. There it is. Okay. So here we go. We have a group of people who want to host a birthday party for a friend. They reserve a room at a restaurant. The room costs $90. an additional cost of $18 per person for food and beverage. So this time the variable is how many people are going to attend. Okay, so when we talk about domain, we have to pay attention to that. So they do not want the person who's celebrating their birthday to have to help pay. So when we divide by X, the number of people attending, we don't want to divide by X because that means that the birthday person has to pay too. So one less person's going to pay. So we're not going to, if there's 20 people there, we're not going to divide by 20. We're only going to divide by 19. We don't want the birthday person to pay. Now, we said the domain has to be greater than 1 because if only one person comes, we're assuming that it's the birthday person and we don't want them to pay, so that means there would be no one there to pay. Also, we say that the thing has to be integers. If it's integers and they're greater than 1, you don't have to worry about any negative integers, but you don't want decimals. So that's why we have to say that we're dealing with integers. And I think it's a double barred Z. That's the notation for an integer. I'm not 100% sure. You need to Google it, but I think it's a double bar Z that stands for the group of integers. I totally could be wrong, so be sure you Google that. So $90 for the room, $18 per person for food and drink. We're dividing it by 1 less than the total number of people that are there because we do not want the birthday person to pay. So what do we do if we have 20 people come? Okay, 20 is the number of people. We plug that in. 20 right here. 20 minus 1 is 19. So we calculate that, we get $23.68 per person, except for the birthday person. They do not have to pay. What if we say that we want the average person to have to spend the average cost to be $25 per person? How many people can come? So you have the function, you set it equal to 25. Now I'm trying to solve. I multiply both sides by x minus 1. That means that this 25 needs to be distributed. So you get 25x minus 25. This side over here, the x minus 1's canceled out, so 90 plus 18x. You get the x's together, so subtract 18x, get the constants together, so you add the 25, and that gives you 7x is equal to 115, and 7x equals 115 divides out to be about 16.44 people. Obviously, you do not want 0.4 people attending, so you either need to round that down or round it up to see if it gets close to 25. I think if you round up, you'll cover the $25 per person. So I think you would need 17 to come. If you just do 16 people come, I think it'll be more than $25. $25 and some change. If you round it up and make 17 people come, it'll be a little bit less than $25. Or I could have that backwards. You do the math to figure that out. Okay, so these are the kind of questions that you're going to have to ask. I am going to tell you that you can go back to lesson 20, all the way back to 27.1 and 27.2. 27.1 and 27.2 take one of these situations and they break it down into about a gazillion questions. That's why I didn't do it in class, because they just take this 5-day camp thing and they break it down into so many pieces. It just lasted forever. So you can go back and look at that and see if you can, read that kind of that type of problem. You'll see what they do to get that type of problem. Here's another type of problem right here. They're doing $800 a day plus, I don't know, a fixed cost of 4 something. But anyway, there's some more examples. I will suggest strongly that for your homework, which is on page 59 something. Let me see where I got it. 59. I'm running out of time. You'll want to probably go back to an example. This example right here. Start back with example B. This is where the problem starts. If you're trying to figure out how to answer this question, go back and read this example right here. And this should give you some background for what you're doing. All right, good luck. Bye.